Okay, so we're going to take a look at Theorem 12. So for this one we're going to use the previous theorem, which is Theorem 11. That was the one about the transversals. So it was this one here, about the parallel lines. If you've got a transversal and parallel lines cut equal segments off it, they'll cut equal segments off any other transversal. So we're going to use that one now. That was Theorem 11, we're going to use that in Theorem 12. So the theorem says, let ABC be a triangle if a line L is parallel to BC and cuts AB in the ratio of S is to T, it also cuts AC in the same ratio. So in order to see what the hell is going on, we draw a diagram. Alright, so we obviously need a triangle ABC. So let's make a triangle ABC. Again, just to try and keep it consistent with what's in the book. If you're looking at that, we label it this way, though it doesn't make any difference. And we're going to draw a line parallel to BC like that. So this is going to be the line L. And it cuts AB, so AB in the ratio of S is to T. So this is S is to T. Okay, and we want to know what ratio does it cut AC in, so in other words we want to know what's this ratio over here. Hopefully it will be S is to T, that'll be great. That's what we're hoping to prove. So just to kind of follow what's in the book and to make it a bit handier, we'll call this point Y and this point X. Right, well, what are we given? So we're given a triangle ABC. We're given a line L which is parallel to BC, and it cuts AB at X and it cuts AC at Y. And we are also told the ratio here, so we're told that AX, so the distance AX over the distance XB is equal to S over T. So that's what ratios mean. If two things are in a ratio of, would say 4 is to 3, then that means this divided by this is 4 over 3. If they're in the ratio of 2 is to 1, then this divided by this is 2 over 1, which is 2. This one is twice as big as that one. So ratio is a fraction, and that's how we're going to write them in the proof. We're going to write them as fractions. So that's what we're given. Let's write down what we need to prove, and then we'll do the construction, which is kind of, as ever, the key to the whole thing. So to prove, if you take a look back at the diagram, we just want to prove that this to this is also S is to T. So that's how we write down. So the distance from, so AY divided by YC is equal to S divided by T. So to prove AY divided by YC is equal to S over T. Right, that's what we're aiming for. So construction. Okay, what we're going to do, this is the whole proof here now. So we're going to take this side, AX, we're going to divide it into S equal bits. We're going to take this side XB, we're going to divide it into T equal bits. We kind of work under the assumption that S and T are whole numbers. And because this divided by this is S over T, then each of these little bits has to be the same size as each of these little bits. It's like if this is in the ratio of 4 is to 3. If I divide this in 4 bits and this is 3 bits, each of the little bits will be the same size. Alright, if this is the ratio of 7 is to 5. If I divide this in 7 bits and this in 5 bits, each little bit will be the same. So that's all we're doing, but we're doing it with S and T. So we divide this into S little bits, this into T little bits, all of the bits are the same. What we do then is we use this parallel line, so we draw a load of lines across that are parallel to the line L, so they're parallel to the line BC as well. And this is where we use the last theorem. So if we look at all of these parallel lines here, then these lines cut equal segments off AB, so that means they're going to cut equal segments off AC. All these little bits are equal here, they're all the same, so that means all these little bits here are going to be equal as well. There's S little bits cut off AY, there's t little bits cut off AC, so that means AY divided by YC is going to be S divided by T. That's the plan. So let's write down the construction. So the construction is we divide AX. Now it's important to put the square brackets on that there, because we just want to divide the bit of the line between A and X into S bits. We don't want to divide the whole line, remember, goes on forever in both directions. So we don't want to go dividing that into S equal bits, because we can't, because each bit would have to be infinitely long. We'd have difficulty drawing it. So we only want to divide the bit from A to X, so that's why we do the square brackets around it. That means the line segment. So we divide the line segment AX into S equal parts, and we divide the line segment XB into T equal parts. And one bit that's left out of the proof in the book, and that we do need to say, is that as the distance from AX over XB is equal to S over T, all these equal parts are the same length. Alright, so we'll try and get that in focus there. So this bit is left out in the book, but we do need to say that because the ratio of the two lengths is S over T, all the equal parts are the same length. So we do need to say that because AX over XB is S over T, that means that all of these equal parts will be the same. Alright, so that's the construction. We have the division done, and from each point of the division, draw a line parallel to the line L or parallel to the line BC, whichever you like. So that's the construction, and they're all these red lines here on the diagram. Okay, and now all of these bits are equal. That means that where they hit over here, all of those bits have to be equal. There's S of those bits here, there's T of those bits here, so therefore this divided by this is S over T. Alright, so just to write that down, so the proof now says that as the parallel lines cut off segments, move that over, cut off segments of equal length from the line segment AB, they will cut off segments of equal length from the line AC, and that is by Theorem 11, which it's probably easier, because we only have these three theorems we need to learn off. For these three theorems, it's probably easier just to learn the number of the theorem, to be honest, rather than by the theorem that says the transversal cuts blah 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 blah. Okay, so as the parallel lines cut off segments of equal length from AB, they have to cut off segments of equal length from AC. So AY, just make sure that is, yeah, so AY is divided, AY is divided into S of these, and YC is divided into T of these. Therefore, the distance AY divided by the distance YC is equal to S divided by T. And we're finished. So that's the whole proof. You do need to say that you've used Theorem 11, and that's it then. Again, everything's in the construction, so if you can remember the construction and you can remember how to phrase it, then you'll be grand. The actual words don't matter that much once you have the idea. That's the main thing.